How does Faraday's law create induced current? Imagine a wire coil sitting quietly, then suddenly a magnetic field around it begins to change. What happens next might surprise you. This is the core idea behind how electric currents can be generated without batteries or direct contact. Faraday's law explains this phenomenon perfectly. It states that, when the magnetic flux passing through a conductor changes, an electric voltage, called electromotive force, is produced in the conductor. This voltage can push electrons to move, creating a current. Magnetic flux is a measure of how much magnetic field passes through a specific area, like a coil of wire. If the magnetic flux stays the same, no current is induced. But if the magnetic flux increases or decreases, the conductor experiences a change. This change can happen in a few ways. For example, moving a magnet closer or farther from the coil changes the magnetic flux. Alternatively, if the magnetic field itself gets stronger or weaker over time, that also causes a change. Or, if the coil moves through a magnetic field, the flux through the coil shifts as well. Faraday's law tells us that the induced electromotive force is proportional to how quickly the magnetic flux changes. The faster the flux changes, the higher the voltage. The law is written mathematically, as mf equals negative number of turns in the coil times the rate of change of magnetic flux. The negative sign is important because it indicates the current flows in a direction that opposes the change in flux. This is known as Lenz's law. It ensures energy conservation by resisting the flux change. In practical terms, whenever the magnetic environment around a conductor changes, an EMF appears. If the circuit is closed, this EMF causes electrons to flow, creating an electric current. The more rapid the change, the stronger the induced current. Increasing the number of turns in the coil also boosts the EMF proportionally. This principle is behind many electrical devices. For example, in a transformer, an alternating current causes a changing magnetic field in one coil. This changing field induces a voltage in a nearby coil, allowing voltage levels to be increased or decreased. In electric generators, mechanical motion moves a coil or magnet, changing the flux and generating current to power homes and industries. The physical mechanism involves the electric field created inside the conductor by the changing magnetic flux, which pushes charges and creates current. So, in essence, Faraday's law creates induced current by converting a changing magnetic flux into an electric voltage. This voltage then drives electrons to move, producing a current. The entire process hinges on the fact that any change in magnetic flux results in an opposing EMF, which is fundamental to how many electrical systems and devices work every day.